Okay, a very important concept in mathematics is, or in functions, is being able to sketch graphs. Now, when it comes to sketching graphs, I think one thing that we need to remember cardinally is that when you sketch a graph, any graph, it actually is a stretch or an extension of a parent graph. So for you to become very good at sketching these graphs, you have to know parent graphs very well. Okay, so now what are these parent graphs? So the first one that we look at is the linear. So we look at the linear. So when we look at an odd function, why is it odd? It's odd because if I had something like this, if I put a negative value here, I'm going to get a negative there. If I put it positive, I'll get a positive here. Okay, so that makes it into an odd function. Okay, it doesn't give you positives from negatives. The easiest way to think about it. So a linear function, the parent function is going to be the one that passes at the origin like this. That's a parent function. Then stretches, extensions, or movements from this are going to be the function that you get. For example, I can put this as y is equal to minus x. Okay, that function will change and become like this. But it's just a change of the parent function, which is y is equal to x. So we need to know that. Another crucial change that happens to this function is when I take this same function and create a magnitude of the same function, okay, like that. So what happens here? We have the same function, okay, this same function, and remember it was going through like that. You can see it from here, right? You can see it from there. Now, what will happen is that because I'm looking for positive values only, this will come here. And so my new function will be this side. So if I were to get that function and find a magnitude of this, then the function is just this one here. And that side, and that side there. Okay. This. That's what becomes of this function. Okay, so we can also look at another type of function. Another type of function is the quadratic. Okay, this we looked at many times, and it all has this form. Then you have extension. So for example, I can have x squared plus 2x plus 3. Okay, but you see, this is the parent form of that function. So it's also going to pass through the origin. Remember, we said that that was the origin. Then the graph will be like that. Okay, these are supposed to be equal. It's just a little bit difficult to draw it, but that will be our quadratic. So if I put a negative here, maybe this function, which is, if I put a negative here, for example, y is equal to minus x squared, it will be that same function, but it will come like this. Then we end up with a maxima here. The other one has got a minima. This one has got a minima. This has got a maximum. Okay, so you can stretch, you can extend this function, you can move it around just based on these numbers and these numbers that you're adding to it. Okay, it can be maybe y is equal to x minus 2 squared. Okay, what has this done? We need to be able to understand. Does it take this graph this side? Does it take it that side? So we need to understand, does it, if I take away, for example, that graph might become something like this. Okay, so we need to understand these stretches. If I added maybe a 2 there, does it go up? Does it? So we need to know how it will go through all those. Okay, so this is the parent function. Here, what we need to walk away with is what is our parent function. So that's our parent function of x squared, of a quadratic function. So we need to be able to to have that, right? Then we can have the opposite of this, which is y is equal to root x. What happens to that function if we say it's root x? Again, we say that we cannot have negatives, so this function changes to something like that. Okay, so that's x squared. This one here, and that is root x. So we have to have a very good understanding of what happens to these graphs as we make those adjustments. Okay. Okay, so another one is another parent function that's important is the cubic function. So this would be like x3 like that. Okay, so how do we map this one? This one will be something like this one goes this side. Okay, it comes and passes through the middle here. So this one will be like this. That will be a cubic function. Again, you'll have those translations. You can have horizontal shift, then you can have the vertical shift as well. Okay, or what they call the stretching. Okay, so we need to know what happens there. Then we have another one. Let's say this same function, we have y is equal to same cubic function like that. Okay, what will happen to this? What will happen to this graph? Okay, so we need to be able to know that this one just shifts and becomes something like that. Okay, so that's the cubic function. This one here, okay, we have, let's say we're looking at the exponential, okay, exponential function. So what is an exponential function? You'll have something like this, for example. The primary function is going to be like that, going that way. Again, if I added a 2, what does it mean? Where is this graph going to be? If I added a 2 there, what does it do? So the parent function of an exponential will be that. What about the one for log? Because we know that log is opposite of log is the opposite of exponent. So what happens here? Remember, this function was going up. What happens here? Should not touch this. It comes from down here. Difficult to draw. Okay, something like this. Okay, you can check these functions, they're everywhere. Okay, so those are those functions. What other functions can we learn? We can look at the parent function. So these you need to practice. You can't really be good at sketching if you don't know the parent functions. So I'm just giving you examples. Okay, so that's 1 over x. What's that function? Again, we're going to have it here, and then the other side would be like there, right? Okay, so that's 1 over x. What about y is equal to 1 over x squared? Now we've gone to an even function. So remember, even function, you will not find it in the negative side. This will be here, right? This is even, right? And then maybe the last one that you need to recognize also is y is equal to c. Y is equal to c. Remember, we have mx plus c, but where we don't have gradients, the line is just going to be like that. This is c, or you can put it there, c. So y is equal to c there. So these are some of the parent functions that you just need to know for you to become good at sketching these functions. Okay, see you in the next session.